Well, first off, I would recommend if you're in the throes of this problem right now is not to bury your head in the sand and say everything is just fine. Everything is just, it's just going to be great. It's okay. This is not a time for positiveness, okay, to be positive.
Don't be optimistic.
We're at DEFCON 1. This is the problem, and it's got to be solved, okay? So I believe that, first off, you've got to, what I tell our designers is that you've got to prepare. Be prepared. Make design based on the fact that you're going to have this problem up in the forefront. So one of the things that we have now really done is we've been proactive regarding this. We've been prepared and proactive. And one of the ways that we've done that is, number one is we have designed out of the norm. Meaning that we have looked at what has been the common line design guidelines.
Right.
And we've stepped out of them, meaning this. If you have an IC on a board and you're going to attach a bypass capacitor to that PCB and that component, you're going to use a 0.1 microfarad capacitor of some value or some size at some tolerance, for example. So the first thing that we do is, can we change the value of that? Does it need to be a 0.1?
Okay.
And then the next thing is, can we change any of the other parameters involved that is the norm that most people are going with?
Right.
So we say, okay, 0.1 microfarad at a 1%. All right, well, does it need to be a 1%? No, it can go up to 5%.
Okay.
I find that a lot of times designers, they over-design their product.
Right.
They over-design it and they go, yes, this has to have a 1%, capacitor in it.
Right.
I remind them that, is this a device that requires such a high standard?
Right.
Is this a medical device, for example, or is this a military device that requires such a stringent guideline?
Okay.
If not, then what we do is we start adjusting our values, we start adjusting our tolerances, especially. Other parameters that you can look at is the temperature ratings and different things like that. So what we start doing is we start getting out of that normal path of design.
Sort of thinking out of the box.
Yeah.
Looking where you can sort of fudge.
Right.
Here and there, but
Exactly.
still stay within the performance needs that you need.
Sure. Right.
Right. But yeah.
But
so
what we're doing is
make no assumptions.
Yes, make no assumptions. And what we say, well, look, there's now a bigger supply of parts for 5%. Now, the other thing is that we've had to do is we've had to be proactive regarding this problem. It's not going to go away anytime soon.
Right.
We have to be proactive. The normal path that we normally took in our design process was that we built the boards, we took it over to an assembler, and the assembler would then look at it and they say, oh, by the way, we can't get this part. All right? It's on order, or it's this or that.
Right.
All right? That was the old way. Now what we're doing is, in the courtesy of this company that started in Australia named Altium, that they have this tool called Active BOM. And what we've done is we've now actually started, as soon as that schematic is done, we take that schematic and we run it into the Active BOM, and we immediately get red flags of what components are not recommended for designs or not recommended for to move forward. So we also get those components that are obsolete, because a lot of times what happens.
So you're checking it at the schematic level before you start laying out.
Yes.
So that's being very proactive. I see what you're saying. Okay.
Very proactive. And then we can go back to the EE or the person responsible and say, look, that's not recommended. And I've actually had a couple engineers go, well, don't worry about it. It will work itself out. No way, no. No. We have gotten into the situation where we actually placed parts. I tell you, it was so bad, and this is a story, that it was so bad that we actually placed an order for parts. Before we could cut the PO, a few minutes later, the parts had already disappeared on us. So
wow.
One of the things that we are trying to do is be proactive. at the very front, and one of the major tool that we're now using to do that is Active Bomb. And we're running that schematic right through Active Bomb. We're getting our red flags, and we're saying, okay, these are going to be our problem children right here.